So I'm going to be covering hypothesis testing for one population. This problem reads, a company claims that when parents use their gender selection method, the chances of having a girl will increase. Assume boys and girl births are equally likely. In a clinical trial of 120 births for parents who used the gender selection method, 76 were girls. A hypothesis test involves various steps. The first step is identifying the null and alternative hypotheses. So there are some notations and some things you need to know. You need to know these notations, what they are. So if you don't know them, familiarize yourself with them. So the first step in identifying the null and alternative is to identify the claim, is to write the claim or identify the claim in symbolic form. So the first step in that is you have to ask yourself, well, what parameter are we dealing with? So in this case, notice that we're dealing with a part of a whole. So for example, we're looking at the part which are girls out of a whole number of births. Because this is a part of a whole, we're dealing with a proportion. So our claim is going to contain the notation for population proportion. And also notice that our claim states that the number of girls or the chance of girls will increase. Well, first of all, what's the chances of a girl in this problem? We're given that boys and girl births are equally likely, so we know that the chance of having a girl is 50% or 0.5. So by stating that there will be an increase in the number of girls, what we're saying is that the proportion of girls is greater than 0.5. That's what the claim is saying, and this is how we state the claim in symbolic form. Once you have the claim, you can then identify or determine the null and the alternative. In the notes, in my class notes, it's detailed what the null is and the alternative is, but I'll just tell you in this video, I'll give you the simple way to figure it out. The null always has an equal sign. So if you go back here and you look at what I have here, the null always has an equal sign. Again, there's a long or detailed explanation for that. Please refer to the notes for that explanation. So P is equal to 0.5. The alternative is either the same as a claim or it's the opposite of the claim. So again, I'm not going to go into detail on what those are, but this table, if you reference this table, you'll always get the correct answer. So in this case, then the claim has a greater than sign, which means the alternative is going to be the same exact statement as the claim. All right, step B. Step B says use a significance level of 0.01 to test the claim using the p-value method. So the next step in a hypothesis test is testing the claim. And in this video, I'm going to go over a testing method called the p-value method. P-value stands for probability value. And with the p-value method, you need to calculate two things, the test statistic and the p-value. Using the TI-84, so these are TI-84 or 83 plus, these are the functions that would give you those two values. So if you're dealing with a population proportion, you're going to use one prop z-test. If you're dealing with a population mean, you're going to either use z-test or t-test, depending on whether sigma, the population standard deviation, is known. So let's see what we're dealing with here. So we're dealing with a proportion, so we are going to use, we're doing the p-value method, and we're going to use one prop z-test because we're dealing with a proportion. Now, before we actually do this, before I show you guys how to find those values using the TI-84, I kind of want you guys to understand what we're doing here, what we have here. So let's go back to our clinical trial, our sample, and here's what we have. So we have a sample where N is 120, right? There's 120 births. That's the sample size. X, which is the number of success, in this case, girls are success, right? 76 girls. And let's look at the proportion of the sample proportion of girls in our sample, or the proportion of girls in our sample. So that's 76 over 120. Let's calculate what that gives us. So 76 divided by 120, which gives us approximately 0.633 or 63%, right? 63.333%. Now, you might look at this and you might say, isn't this sufficient evidence to support our claim? Our claim says that the population of girls would be increased, is greater than 0.5, if the parents go through this gender selection method. Well, isn't this greater than 0.5? Why? And here's another question to think about. Now, why could we not use this, just use this by itself to say we're going to support the claim? Here's why. Because this is a sample. This is a sample of 120 births or 120 parents who gave birth, and we could have just gotten lucky and had this proportion of girls' births which is greater than 0.5. So with the p-value method, what we're going to do with that is we're going to calculate the probability of getting this result. Whether was this just obtained by luck, or is there something going on? All right. So we are going to need two values. The first one is the test statistic. And you can think of the test statistic like the z-score, the t-score of the result. And the p-value is the probability of getting this result. All right. And it's also very important that you do not confuse this p with this p. This p right here is the population proportion of girls, right? In our problem, this is the population proportion of girls. This p right here is the probability, the probability value. And the probability value is the probability of getting this result. All right, so let's go ahead and use one prop z test. So we're going to go stat test, one prop z test, one proportion z test. So enter. This p sub 0 or p naught is just the value in the claim here. So that's 0.5. And then x is 76. N is 120. And this next line right here, this is the alternative hypothesis. So in our alternative hypothesis, there's a greater than sign. So we're going to choose that. And then we're going to calculate. This is the test statistic. This is the p-value. Again, this p, do not confuse this p with this p right here. This is the p-value, which is the probability of getting this result. This p right here, these p right here, they're representing the population proportion of girls. All right, and then this p hat is a sample proportion, which is we calculated right here. Okay, so let's write those down. The test statistic is usually rounded to 2 decimal places, so the test statistic is 2.92. P-value is typically rounded to 4 decimal places, 3 or 4 decimal places, so in this case it's 0.0017. So the probability of getting this result is 0.0017, which is a very small probability. In other words, if we get this result, and this result is greater than 0.5, then what we're suggesting is that we probably didn't get this result by random chance. Something's going on. And if all things being equal, meaning if you look at other births with other parents and you look at what's going on here, all things being equal, if the only thing that's different between those other births and this births is the gender selection method, then it's the gender selection method that's causing this result. So hopefully that makes sense. Another question is, well, how low does the probability have to be? When is it low enough to where we can say that this probably didn't happen by random chance? That's where this significance come into play. So the significance level is always predetermined in any statistical test. It's always predetermined. It's represented with the Greek letter alpha. So what we do is we compare the p-value to alpha, the significance level. So with the probability value or the p-value is so low, lower than significance level, We say that this result didn't happen by random chance. Something's going on. And in this case, it's probably the gender selection method that's causing this increase in proportion of girls. All right, so p-value is 0.0017, alpha is 0.01. Clearly, the p-value is less than alpha. Now, what do we do from there? One thing I forgot to mention is that we always assume that this is true, that the null hypothesis is true. With every hypothesis test, we always assume that the null is true. So we assumed initially that p is equal to 0.5, but we found evidence contradicting that. So when the p-value is less than alpha, in other words, when we found enough evidence to where we say that it wasn't random chance that we got this value, right? This value which is greater than 0.5, we reject the null hypothesis. We assumed it to be true initially, but we're going to reject it because we found evidence to contradict it. All right, now there are here's some notes on that. So anytime the p-value is less than alpha, we are going to reject the null. If the p-value is greater than alpha, then we're going to fail to reject the null. All right, and then on to the conclusion. We have to make a conclusion and kind of refer to this when you're working through your homework, but I'll walk you guys through this example. So by rejecting the null hypothesis says that the proportion of girls is equal to 0.5. We're not supporting the null, right? We're rejecting it, so we're not supporting it. We're not supporting it, and we're supporting the alternative. So it's only you either support the null or you support the alternative, one or the other. And because the alternative happens to be the same as a claim, we are going to support the claim. So here's our conclusion. There is sufficient evidence to support the claim. Okay, so hopefully that helps. Hopefully it made a lot more sense now. Just remember that depending on which parameter we're working with, whether it's population proportion or population mean, you're going to be using different functions on the calculator. Also, sometimes on your homework, especially on your homework, these will not produce the correct answers. They may be off by several decimal places. The reason is the book, and when you guys work on my stats lab, some of the answers are obtained using the formulas, and some of them are obtained using the tables as opposed to technology, like where we're using the TI-84. So in some cases, you have to use the formulas. These values here that we got here we used the calculator. We used one prob z test, and it was very simple to get. But in certain cases where if you're not getting these answers or your answers aren't correct, you will have to use the formulas to get the test statistic or the p-value. So the formulas are here for the test statistic. If you're dealing with a proportion, this is the formula. If you're dealing with the mean, the population mean, depending on whether you're in a t-distribution or z-distribution, these are the formulas. And if you're dealing with a standard deviation or variance, you're in the chi-square distribution, which means you're going to be using this formula for the test statistic. In regards to the p-value, it's a little bit more complicated. I would highly suggest you refer to the notes on how to do that, but pretty much you have to determine whether it's a left-tailed test, a right-tailed test, or a two-tailed test. And real quickly, I'll tell you how to determine that. If the alternative has a less than sign, it's a left-tailed test. If the alternative has a greater than sign, then it's a right-tailed test. And if the alternative has a not equal sign, then it's a two-tailed test. Those are the only three situations, and these are the only three types of tests you're going to get. All right, so again, hopefully that was very helpful. If you have any questions, feel free to shoot me an email.